I'm Joanne Taff, Editor-in-Chief of TM Forums Inform, and I'm delighted to have with me Vance Shipley, CEO of Sigscale, and Andy Tiller, who's TM Forums Executive Vice President of Member Products and Services. And they're here to discuss the use of WebAssembly in the telecoms industry. WebAssembly is a computing standard designed to make it much simpler and much more efficient to securely run applications that are distributed horizontally to all sorts of devices on the cloud, across different networks, and to the edge. Vance, you've been heavily involved in the TM Forum Catalyst with several telecom operators. You've been demonstrating how to realize an ODA Canvas on a WebAssembly cloud and use it to create ODA components. But actually, before we start looking at WebAssembly in depth, Andy, perhaps you can provide us with a bit of context and explain about what TM Forum's open digital architecture is and the Canvas as well.
We can give you some background on the ODA components and Canvas. So ODA, Open Digital Architecture, is an enterprise architecture blueprint which is designed to replace traditional OSS and BSS software with a more cloud-native approach, which is much more agile. So a central concept in ODA is the ODA component, which we represent by this hexagon. These are the Lego building blocks of a plug-and-play software architecture. And on the right, you see the map of ODA components. Each component has a core function represented by the green part of the hexagon there, the green rhombus at the top. So it might be billing invoice management or product catalog management, or it could be a resource inventory component. And those core functions are exposed through open APIs defined in TM Forum's API project. But you see also the other parts of the hexagon, the other colors. These represent the supporting functions, which relate to things like security and observability and other management functions. So managing the software in a cloud environment. And that's where the Canvas comes in. So the Canvas is the runtime environment for the software components. It provides common services for all of the components, things like managing security and party roles, those kinds of things. And in ODA, what's critically important is that we are, first of all, standardizing both the components and the Canvas. But secondly, that the components of Canvas are defined implementation agnostic. So in other words, even though today most operators are, where they're deploying the Canvas, they're using a Kubernetes environment, they're deploying the ODA components as containerized applications into a Kubernetes environment. That's pretty much the standard today, but it doesn't matter if you use a completely different approach. The standards still apply, and you can build an ODA Canvas and ODA components using very different approaches to building software. And that's what's exciting about the WebAssembly Canvas that Vance has been pioneering, where we're taking a very new and different approach to building software, but we're still creating something which is compliant with the open digital architecture.
So Vance, perhaps you can explain a little bit about what WebAssembly is and in what situations it's useful for telecom operators.
So the World Wide Web Consortium, W3C, has specified WebAssembly as the fourth language for the web after HTML, CSS, and JavaScript. So if you look at JavaScript, the source code for JavaScript is interpreted by the web browser, whereas WebAssembly is compiled code, performs a similar function, but one is interpreted and one is compiled. Now, to make this work, the W3C specified a new type of virtual machine, which is independent of the programming language, operating system, platform, or CPU architecture. This allows web applications to be written in any programming language which has a compiler supporting the WebAssembly target, and then run anywhere that supports the standard WebAssembly virtual machine. Now, this is the important part. WebAssembly is a safe, portable, compact, and efficient standard for shipping and running software anywhere, not just in a web browser. Today, WebAssembly is supported on every major browser, but also on many other platforms, such as CNCF's WASM Cloud. WebAssembly is ideal for applications where software is sent across trust boundaries, as it may be safely sandboxed and run securely, even when it's coming from untrusted sources. Distributed applications, which may need to run on various platform architectures, such as edge use cases, are also a great fit. And finally, any application which needs to scale down to run in a minimal environment is a good candidate for WebAssembly.
How does it fit with the ODA Canvas work?
Open Digital Architecture, or ODA, provides a framework for composing applications from ODA components, which are themselves specified in terms of their interfaces. So ODA is platform agnostic. The concept of an ODA canvas specifically covers the application environment in which ODA components live. We have a reference implementation for Kubernetes, which was first demonstrated in the Boss Catalyst, which I participated in. But more recently at DTW 23, I led the WebAssembly Canvas Catalyst, where we demonstrated ODA components implemented on CNCF's WASM Cloud open source platform. So this example of an ODA canvas realizes ODA components with WebAssembly running as actors in WASM Cloud. To highlight how this enables different use cases than the Kubernetes canvas, the hardware platform in our kiosk was a cluster of tiny ARM servers consuming only a few watts of power, which we metered to show. We wanted to provide a concrete example of an ODA canvas on a platform other than Kubernetes. For phase 2, we proposed to demonstrate feature parity and federation between the canvas types. Our work will aid the ongoing specification of a technology-independent ODA canvas.
What aspects of WebAssembly are most attractive to operators, and how important is energy efficiency?
It comes into play in a lot of different areas, but the main thing is that the WebAssembly application stack is a good deal smaller than it would be in a container-based environment. And so just having less code, moving around less code, loading and unloading and running and putting it into memory, et cetera, all of that requires energy and creates emissions. So the smaller you can make things, the more energy you'll save. But the other thing is about workload placement. So if we're able to match the workloads more closely, we're able to use them more efficiently. And so that's an important aspect of it as well.
And I suppose, does that save internal sort of development time as well?
Yeah. So because you can eliminate a lot of extra complexity, you then make it easier to develop and manage. So that's also a big part of it. Now, the WASM Cloud platform, which is one of the available platforms for WebAssembly, WASM Cloud has made a great effort to separate the business logic from services. So services are provided by providers actually, and that is separated out from the actual applications, which are just executing the business logic. And there's a number of reasons why this is really beneficial. One of which is for security and basic cost of operations, because if we have a common set of providers, then we can manage those and upgrade them when needed, et cetera, without affecting any of that business application code. And the security part of it is really important as well, because all of the WebAssembly code runs in a highly sandboxed environment.
And I understand that WASM Cloud is still in pre-production. How and when would you expect the telecoms industry to start using it for mission-critical applications?
The CNCF WASM Cloud project roadmap has a version 1.0 release planned for Q1 of 2024. So that becomes then a production candidate. There are other WebAssembly runtime environments, both open source and proprietary, available today. So you could conceivably get started right away. Realistically, I would expect WebAssembly to first be used where securely portable software is required, such as FAS, functions as a service, in cloud offerings or internally for hosting closed loop automation functions. As the WASI system interface specifications mature, we'll start to see more general use of WebAssembly probably in 3 or 4 years.
Vance, maybe I could just chip in with a question or two. As in our everything in our industry, changing the software stacks is a migration process. It's always brownfield. The industry is in the process of moving from sort of legacy environments to microservices, and then we have WASM and other newer technologies coming along to help with the software build. How does WASM fit to an existing environment? So let's say, first of all, for a network operator that's perhaps begun to build out software on an ODA Canvas in Kubernetes, can they introduce a WASM Canvas alongside it?
Yes, absolutely. One of the things is that you would likely deploy the WASM cloud platform application itself in containers. It's a distributed application, so it fits quite well to be managed by Kubernetes. But one of the important things about WebAssembly is, again, it's a compilation target. So that means that any existing applications which are written in a programming language which has a compiler which targets WebAssembly can be retargeted for that environment. So it doesn't mean having to rewrite code in a new language or anything like that. We can retarget the code to this environment. And yes, it's another migration. It's not going to be a small job, but the big thing about this is that as we're creating now a new standard for running software, shipping software, composing software, in the future, once we are on WebAssembly, then moving to different platforms, it is very easy because there's no change. So this is a virtual machine technology. So you've got this WASM stack machine, and that's implemented by different environments. And whether it's an ARM CPU or a IBM mainframe, it wouldn't matter, right? It's the same code can be shipped. So then you're able to move these workloads as built and at runtime and move them somewhere else. So yeah, there's a bit of a migration effort to begin with, but in the future, those migrations are going to be really much less of a problem.
As a software vendor, building software components on the ODA component map we saw earlier, where are the best places to start? Which of the applications on the map can benefit most, do you think, from going to a WASM approach?
I think initially, when you look at that, the ones that have requirements that WebAssembly just does better than anything else are certainly going to be the first ones that you're going to look at. So as I say, where you need portability, where you need distribution, where you need security, those are the important parts. So in our Catalyst project at DTW 23, we're demonstrating some use cases with Orange where we were doing rating as a distributed function. And so you're actually taking that rating function from a third-party service provider and then hosting it, running that rating function as provided. So that's coming from a third party. You really need to be concerned about security in that case. And also just-in-time delivery, like being for that third party to be able to be updating that rating function or customizing that rating function and giving us a new one to run during the life cycle. That's the sort of thing you really couldn't do in most other ways. So that's what I see as being the first thing. The other big thing about it is the instantaneous nature. So because this virtual machine is dealing conceptually at a different level, when you want to start a new process, if you look at Kubernetes, starting a container takes at least 5 seconds, but you can start a WebAssembly process in microseconds. So it's a totally different thing, and you really need that level of instantaneous response for proper functions as a service, for example. So any of the applications where these superpowers that WebAssembly brings are the first ones you're going to look at. But what we did in the WebAssembly Canvas Catalyst project is we demonstrated that we can do normal components. We implemented product catalog, product inventory, service inventory, 3G converged charging server, and all of those were implemented in WebAssembly and run as actors in the Wasm Cloud environment. And we really demonstrated how all of those things can be very practically addressed this way.
It's a very, very important proof point, I think, for ODA and pointing to a secure future. I know the Catalyst materials are available online for people to watch. What have you got next planned for another phase of the Catalyst, Vance?
So in the next phase, what we want to concentrate on is demonstrating feature parity with the Kubernetes canvas. So we're going to have both of those canvases running, and we're going to run the same workloads and show that we've got equivalency. And then secondly, we want to demonstrate federation. So where we have the two types of canvases federated together. So an example would be discovering components on another canvas and using those components.
And I look forward to seeing that. You'll be showcasing that at DTW 24, is that right, in June in Copenhagen, Vance?
Yes.
Oh, great. We'll have to come along and have a look. It's a really interesting project. Thanks for taking the time to talk about it, Vance and Andy. And as I look forward to seeing that in Copenhagen. Thank you.